In this video, we're going to be talking about solving absolute value inequalities. So these are different than equations in that the answer will be a solution set and not just a single x value at a time. So looking at this first form, this is the less than form. It's when you have an absolute value less than a number. Now let's think about this, what it means for these solutions. So if I had x, the absolute value of x is less than 3. Remember, absolute value itself means all the distances, right? So I want all the distances less than 3. So let's look at what a graph of that might look like. So in general, I'm starting at 0. Just drawing some numbers here. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, so I've got this number line here. And I want all of the distances that are less than 3 units from 0. Right? So I don't have anything going on inside this absolute value. It's just x. And that means I want all the values of x, but the distance is less than 3 units away from 0 in this case. These shifted on the graph, but this is just x. So looking at my chart, right, so the furthest I can go would be to 3. And the furthest back here I could go would be 3. Right, so from 0 to here, anything between 0 and 3 would be a distance less than 3 units, right? And I go over here to this 3, so this negative 3, so I forgot to put the negatives on there. This is 3 units from 0, so that has a distance of 3 units from 0. Even though it's in the negative direction, the distance itself is 3. And then anything between here to 0 would be a distance less than 3. So the solution says everything between negative 3 and 3. We can see that this actually ends up being a conjunction or a closed interval here. And we're going to use that to solve. Anytime I have a less than, the distances are going to be closed together in this finite space. Right? So when I solve an absolute value inequality that is in the form less than, I'm still going to start by isolating the absolute value, just like we did with the equations. So looking at this example here, I would add 2 to both sides to get that absolute value alone. And I have x minus 2, that quantity less than or equal to 3. So I want this inside, so now it's no longer x. It's not going to be starting at 0. It has shifted. But this quantity x minus 2, I want all the distances that are less than or equal to 3 units away. So the way we can solve this, because I know it's going to be a conjunction, is I can say, well, this could be a distance of positive 3 or a distance of negative 3, right? Because the absolute value of negative 3 would be 3 units from 0. So I'm going to tack on negative 3 less than or equal to what was inside my absolute value, less than or equal to 3. Right? So this sets it up to all the values in between 3 and negative 3. So if it's a less than, we can tack on the left-hand side here. The arrows will continue to travel in the same direction. I shouldn't say arrows, the inequality. They'll be facing the same way. But really, you read it from the variable out. So this says x minus 2 could be greater than or equal to negative 3. Right? Greater than means go up. So I'm going up, all the values up from this value down here. But it's setting it between these two distances. The max I can go is here and there. And everything in between will be part of my solution. So now we've solved this in previous videos. I know I want to get x alone, so I add 2 to all my sides. So to each section of my inequality, negative 3 plus 2 is negative 1, less than or equal to x, less than or equal to 3 plus 2 is 5. So now I know it's between negative 1 and 5. If I wanted to graph this on a number line, I'm going to start at, let's see, put my 0 down here, and then negative 1, and 1, 2, 3, 4, 5. And I know it's going to be the set of values in between. Because I have this equal to bar, I'm going to use a bracket or a closed point. So I like the brackets because that's how I write it in the interval notation. And the same thing here with the 5, using a bracket to include that as part of my answer. And then everything in between is part of my solution. So when I go to write this in interval notation, it'll look just like this, reading it from left to right. Starting at negative 1 and going up to positive 5, including both of those in my solution. Alright, so again, that's the less than. The idea is it's all the distances that are less. They're coming together. It's going to be this closed interval. Now when I look at this, I've already isolated my absolute value. It is a less than statement here. And it says the absolute value when all the distances are less than negative 13. Well again, the absolute value itself, whatever value I end up inside, once I take the absolute value, it's going to be a positive number. Right? Even if I had negative 23 in here, the absolute value of negative 23 would be a positive 23. So when is a positive number less than a negative number? Positive numbers are never less than negative numbers. So I'll never find a distance that's less than negative 13. Right? Distances are positive numbers. There is no distance that's less than a negative number. This one has no solution. We don't have to do any more work. So we can write that with this notation or an empty brace to show the empty set. Try the 2 on the right. Alright, here we are at this example on top at the right. Whenever we solve absolute value equations or inequalities, we want to isolate the absolute value first. So first I have to get rid of everything else outside of the absolute value. I'm going to start by subtracting 3 from both sides. Remember, this is joined with multiplication, so I'll do that last. I have 9 minus 3 is 6. Then I undo this multiply with divide. Whatever I do to one side, same thing to the other side. Oops, this was not equal to here. Let me erase that. Alright, so now we have the absolute value of 2x minus 5 is less than 3. So, I have an absolute value that's isolated. It's a less than form, in this case less than 3. So I'm going to consider the positive and negative distances that it could be. So I'll say negative 3 is less than 2x minus 5 less than 3. Right? It's going to be in between two numbers. It's going to be this closed set here of distances that are less. They're coming together. Now that I have it in this form, I can solve by adding 5 to all 3 parts of my inequality here. So I have a positive 2 less than 2x less than 3 plus 5 is 8. Divide by 2. 2 divided by 2 would be 1. less than x less than 8 divided by 2 is 4. So since this was less than and not less than or equal to, there's no equal to bar here, that means when I go to graph this, I'm going to use parentheses for an open point. I've got 1, 4, and again, they're coming together. It's got to be all the distances less, so they're coming in, and it's everything in between will be a distance less. So there's our graph, and in interval notation, it would be from 1 to 4, using parentheses, because my original was strictly less than, there was no equal to bar. Another way to solve this would be to separate it into two separate inequalities, right? We could say 2x minus 5 is less than 3, and, this would be an and, so in the form less than, I already mentioned earlier, is conjunction, it's an and statement. So we're only going to write the overlap as the final solution. So you could break it up into two if you prefer, of the 2x minus 5 less than 3 and the 2x minus 5 greater than negative 3. So anytime I add that negative, remember I have to flip the direction of my inequality. I prefer not to do that so that I have a way to remember what's the strategy for solving a less than versus what's the strategy for solving a greater than, which we're going to talk about later. So if it's a less than, I remember to tack on the left side and then solve this with the 3 parts. And I know my answer should end up in this form of some closed set. Alright, this last one here. Again, I'm not taking 6 minus 3 to start. I need to isolate this absolute value by subtracting 6. So now I have negative 3 times the absolute value of x plus 5 divided by 2 is greater than or equal to 9 minus 6 is positive 3. And then I divide both sides by a negative 3. And when I divide by a negative, I have to remember to flip the direction of my inequality. So instead of greater than or equal to, this will be less than or equal to. A positive divided by a negative is negative 1. And now I'm back over here like I kind of was before. I have an absolute value, and I want to know when that's less than or equal to a negative number. Again, this is going to be a positive number once I take the absolute value. So when is a distance less than or equal to negative 1? Never. There is no solution. In interval notation, the answer is the empty set. There you can write it with the braces. Alright, in the next video we're going to be talking about greater than form.